Hello everyone. In this video, I will explain how to synthesize RC network using first form. This is the impedance function given in the example. We said RC is equal to S plus 2 over S plus 1 times S plus 3. In Foster form, we are using partial fraction expansion to construct the RC network. This is the impedance function. Before applying the first form, we have to check whether this function is realizable or not. For that one, there are 6 general properties for passive RLC functions. These are the 6 properties. Now we will consider one by one. When we consider the first one, the property is must be a rational function in S with real coefficient. You can see it's function with S and it has real coefficient. Then first one is okay. And second one says may not have poles or zeros in the right half S plane. For that one, we have to find poles and zeros in this function. If we find poles, we can obtain poles from the denominator. There are two roots, S equal minus 1 and S equal minus 3. Then these are the poles. For this function, there are two poles and we can obtain zeros from the numerator. The roots of the numerator is S equal minus 2. Then it has only one zero. Then we can plot poles and zeros in the complex S plane. This is imaginary axis and this is real axis. It has two poles at minus 1 and minus 3. And it has one zero at minus 2. This is the right half plane. According to the plot, there are no any poles or zeros in the right half plane. Then the second condition says may not have poles or zeros in the right half S plane. It is satisfied. And third one is may not have multiple poles or zeros. You can see there are no any multiple zeros. Only one zero. And when we consider the poles, there are no any multiple poles also. Then third one also satisfied. Then fourth one is may not have degree of the numerator and denominator differing more than 1. In this function, degree of the numerator is 1 and degree of the denominator is 2. The difference is 1. It is not more than 1. Then fourth one is okay. And the fifth one is must have a non-negative real part for all S equal j omega. For that one, we have to assign S equal j omega to this function, impedance function. We said RC j omega is equal to j omega plus 2 j omega plus 1 into j omega plus 3. From this one, j omega plus 2 is the numerator and denominator 3 minus omega squared plus 4 j omega. The denominator has a complex number, then to find the real part of this ZRC, we have to multiply numerate both the numerator and denominator by the complex conjugate of the denominator. The omega plus 2, we can multiply 3 minus omega squared minus 4j omega. And the denominator 3 minus omega squared plus 4j omega multiplied by 3 minus omega squared minus 4j omega. For the numerator, we can get 6 plus 2 omega squared minus j into 5 omega plus omega cube. And the denominator is 3 minus omega squared plus 16 omega squared. This is the final answer when you solve this one. And if we consider the real part of ZRC, j omega, we can get 6 plus 2 omega squared over 3 minus omega squared plus 16 omega squared. This is the real part. In the fifth property, it says must have a non-negative real part. This is greater than 0 because all are this omega squared, and omega squared. Then it is greater than 0. Then fifth one is satisfied. And the last one is must have a positive and real residues for false. For that one, we have to find the partial fraction expansion parameters. We have to do partial fraction expansion. For the first of all, also we need the partial fraction expansion. Then I will do the partial fraction expansion to this impedance function ZRC. This is equal to s plus 2 over s plus 1 times s plus 3. We can write it as a over s plus 1 plus b over s plus 3. This is the partial fraction expansion, and a and b are the residues. We have to find a and b, and if a and b are positive and real, the sixth property also satisfied. Now we have to find a and b values. S plus 2 is equal to a times s plus 3 plus b times s plus 1. If s equal minus 1, 1 is equal to 2 times a. Value of a is equal to half. If this s is equal minus 3, minus 1 is equal to minus 2b. B is equal to half, 1 over 2. Then you can see a and a value b, both are real and positive. Then sixth property also satisfied. Must have positive and real residues. These are the a values. Value a and b are the residues. Both are positive and real. Then we can write the expansion. We said RC is equal to half value of a is plus 1 plus half is plus 3. This is the partial fraction expansion, and we have to find elements for each impedance value. This is impedance value 1 and this is impedance value 2. If we consider the capacitor, the impedance of the capacitor we can write 1 over Cs, and the admittance of the capacitor we can write Cs. And if we consider resistor with the value of R, impedance is given as R and admittance we can write 1 over R. We can use these expressions to obtain the final circuit. Now I consider only Z1. Z1 is equal to 1 over 2 times S plus 1. For this one, I consider the admittance value Y1. This is the reciprocal of Z1. It is equal to 2S plus 2. When we consider this 2S, it is like to this admittance of the capacitor. YC is equal to CS. Then this will be a capacitor. The value is 2. And if we consider this admittance part, there are no any S terms, then it will be a resistor and value will be 1 over 2. And these two are admittance value and it is combined by plus mark. Then these two elements are connected in parallel. Capacitor with the value of 2 farad and the resistor with value of half ohm. Then I consider the second impedance is a 2. It is 1 over 2 times S plus 3. For this one also I consider the reciprocal, that means admittance value Y2 is equal to 2S plus 6. 2S is same as the previous one. It is a capacitor. Value is 2F, and for this one it is a resistor. Like previous one, the value will be 1 over 6. And these two are admittance value. And they are combined with the plus mark, then these two elements are connected in parallel, capacitor and a resistor. Capacitor value is 2 farad and CC2. Resistor value is 1 over 6 ohm. We can rename, this is C1 and R1. Now final circuit will be the combination of these two parts. It is given as plus mark, then these two parts are connected in series connection. Then final circuit will be, this is first Z1, capacitor and resistor connected in parallel, half ohm, and this one is the Z2, second impedance. C2 is 2 farad and R2 is 1 over 6 ohm. We can obtain the final impedance between these 2 points. This is the ZRC. And final circuit will be like this. This is Z1 and this is Z2. Both are connected in series because of this plus mark. These elements are connected in parallel because of this plus mark in admittance value. This is the process for first of all, and how to construct the RC network using for this function. First, we have to check the general properties are satisfied for the given impedance function, impedance or admittance function. First, we have to check the properties. Then we have to do the partial fraction expansion, and then we have to find single element for each and every small impedance value, and these are the values. I hope you all are clear with this example. And thank you.